So when we're looking at domain and range of a linear function that models a real-world situation, here's how to think through this problem. The owners of a recreation area are filling a small pond with water. Let W be the amount of water in the pond in liters, and let T be the number of minutes that the water has been added. Time, T for time. Suppose that W equals 35T plus 700 gives W as a function of T. Whenever we say W as a function of T, then basically we're saying the W of T, or this is sort of like the function of X, where, so W is going to be our Y and T is going to be our X, so to speak. And so the reason I tell you this is because Y is always called range when we talk about the possibilities that it can be, and X is always called the domain. So you might want to write that down in your notes whenever it says W as a function of T, they always give you the Y as a function of X. And you need to know that information because you need to know Y is range and X is domain. When we talk about range and domain, we're just talking about what are the limits on those numbers, or what is, in reality, what are we talking about? So here it says, identify the correct description of the values in both the domain and range of the function, then for each choose the most appropriate set of values. So when I want to talk about domain, remember I'm talking about X. So in this case, I'm talking about T, time. So think about time for just a minute. Description of values, is that the number of minutes that the water has been added, or the amount of water? Well, that'll be the number of minutes because we're talking about time. And then choose the set of values. I'm in a screenshot, so I can't select the drop down, but here's how we know what happened. So if you're just thinking about this situation, it says they're filling a small pond with water. So there's got to be a start of time, right? So time could definitely maybe start at 0, and then it's going to take a certain amount of time to fill it up. And they give us some extra information here. It says during the next 60 minutes. So we could start at 0, and then we're going to go for 60 minutes. So somewhere in this drop down is like 0 to 60. Something like that, because that's how many minutes we're going to be filling our pond. That's the domain of the function. That just is what it is talking about when we're talking about the time. And the reality of it, we don't have negative time, right? And we're not going to keep filling it past 60 minutes. So that's what we want to identify as just what's really happening here. Okay, so now we're going to talk about the range. And remember I told you the range is Y, which in this case is W, and W is the total amount of water. So if I look at the choices here, the number of minutes water has been added, or the amount of water in liters, it's the amount of water in liters. So see how domain refers to this variable and range refers to this variable. The drop-down menu is going to tell you, okay, so if we're adding water for 60 minutes, what does that look like? So what we can do here, because it might not start at 0, what we can do here is use our function. So we have W equals 35T plus 700, and we can plug in our starting amount. So let's see what it is if at 0 time. So 35 times 0 is just 0, and 0 plus 700 is 700. So at 0 time, there are 700 liters of water in the pond. So this is actually our y-intercept, and it's where our line crosses the y-axis at 700, because that's our starting amount, and we can actually kind of see that in this form of an equation. The next thing we need to do is just to figure out what is the total amount of water we're going to end up with in 60 minutes. So you want to plug in 60 right here, and you might want to use a calculator for this. So we're going to go 60 times 35. That's our rate. Apparently we are putting in 35 liters of water every minute, and that's 2100 plus 700 gives us 2,800 liters of water. At 60 minutes, we will have 2,800 liters of water. And I just used the equation to figure that out by plugging in the top amount. So somewhere in the drop-down menu right here, you're going to get 60 to 2,800, because that in reality is the amount of water in liters that we're going to have across the time span. We didn't, oh, whoops, I put 60. Sorry, that's silly. 700 is what we wanted. 700 to 2,800. See, I caught myself because while I was talking, I was thinking, is that the realistic amount in this situation? So half the battle is just reading really carefully to figure out what's happening in here. But the second part of the battle is definitely knowing what this means. W as a function of t. W as a function of t tells us that t is going to be our x and w is going to be the output or the y. Hope that helps.